Welcome to this topic video on SVG and the DOM. We're going to try and show you that most everything you learned for working with HTML in the DOM is going to apply to working with SVG. So that means all the JavaScript stuff you've been doing with HTML, you can apply to a nice graphics format, vector graphics format, SVG. Okay, so let's take a look. Okay, first let's look at this simple guitar fretboard diagram. How did I draw this? Oops, not that one yet. I've got an HTML page. I've got an SVG in it. I've set up a bunch of lines to represent guitar strings, which is a musical instrument, and a bunch of lines to represent the guitar frets, and some circles to represent the fingering that one would play. This is an E major chord. Okay. Now, first thing to remind folks is that, let's look at the style sheet that's attached to this. It's an inline style sheet. It claims that these circles, the circle elements we just saw here, circles, it seems to imply that we can just change the fill color by changing the CSS. Oh geez, that's true. Wow. Do you think that applies to the stroke of the strings that are going vertically and the frets which are running horizontally? Let's try changing them from black to green. Okay. So we see, if we forgot, that we can style SVG with CSS. Okay. So that means the look and feel, the look of something in SVG isn't set in stone. We can enhance it, modify it, do whatever we'd like in CSS. Second thing, let's try from the console using some of our favorite items. Let's go document, query, selector, circle. Oops, I want to see all the circles. Query selector, what is it? All. We get a node list of 3 circles, each one of these. Okay, so our queries work that way. Okay, can we do that again? Document dot query selector. Let's go line dot G string, guitar string. Oops. Okay. Forgot my class names. Okay. Query selector, once again, all. Okay. Node list. Now each of my strings, they're the vertical lines, for those who haven't seen a guitar chord diagram. Okay. So we can do that. What else can we do? Let's go get the SVG. My SVG equals, what is it? Document dot query. I just need one of them. Selector SVG. Oh, that gives me the entire SVG. Nifty. Okay. So we can use the DOM for that. Okay. So we tried some query selectors and we saw we can do that. Okay. Results. Well, you just saw the results. Okay. What if we want to create some elements? Okay. All of the SVG DOM interfaces that correspond to elements in the SV language derived from this SVG element interface. There's actually some more that the shapes derive from, but at the basics, they are part of the inheritance hierarchy. Okay, so SVG element is a type element which is of type node. Okay, so we can use document, oh, a little different. Okay, we got to use document create element namespace. Okay, because we're using SVG and not HTML. So we're going to have to use a call like this. Let's say we want to create a square or a rectangle. We go document create element namespace. Then we tell them we want SVG. Okay, that we're getting something from SVG, and then we tell them the type of thing. Okay, all those shapes we learned in the introductory SVG video, you can just put in here: rect, circle, line, etc., etc. Okay, now SVG elements usually have a ton of attributes. Okay, so we use the set attribute call. We didn't use that much before with our HTML DOM, but here with the applying the DOM to SVG, look at all these properties we need to set. Here's a square. Okay, we're going to create a rectangle. It's not really going to be a square because I set the width and height different. Sorry about that. What do? I set the attribute of the top left corner, X and Y. Okay, then I set the width, then I set the height. Okay. Oh, we don't want to go to random square generators yet. Let's try this. Okay. Okay, so over here, let's generate some code. Watch the diagram to see what happens. We're going to paste that code, and nothing happened. Why not? Wait a second, Professor. You forgot to add append child to add the element, the square, or really rectangle, to the diagram, the SVG diagram. Oh, yuck. That doesn't look very pretty. Okay, I got to pull this up a little bit. So we have square. Can we make it look, can we dress it up a little bit? Doesn't matter if it's pretty or not. I'm not an artist. Set attribute. How would we set the color? Oh, that's right. Fill is an attribute. What color do we want to give it? How about aqua? We'll see if that's a real color. Whoa, that worked. Ooh, square. Set attributes. Stroke. What's the stroke? That's the thing that goes around the outside. Let's set that to, let's keep that black. Kind of hard to see that over there on the left, isn't it? Is there an attribute for that? Yeah. Remember, this is SVG. These are drawing things. They have attributes for everything. Okay, what do we want? Stroke. I don't really have these memorized. I practiced this beforehand. Stroke width, let's go with, let's be obvious, 10 pixels. Okay. So we see that not only we can create and add things by hand from the DOM, okay, programmatically to SVGs, okay, and we can try it out just in our browser, okay, and we can try things out if we make our variables global from the dev console, okay. What else could we do? Well, if you can make one square or rectangle, you can make a ton. Okay, so here's my random square program. What does it do? Try and guess that one. Oops. My random square program. Open it in a new tab. What is this doing? Creating a bunch of squares. How many squares? Let's take a look. Okay, max size for, oh, here's a for loop. I call this function 30 times. What does it do? I start off with the SVG, okay, in the drawing, okay. Always have to look to make sure it's there. All right. Okay, here's the SVG. ID my drawing. Okay. So what we're doing is we're grabbing the element. Okay, we're setting some parameters. Okay, coordinates and such like that. Then we start generating random locations, X and Y. Set a random width. Create the element. We set the X, Y, the width, the height. See here, these are true squares. I only have width. Okay. Oh, look. Generate a random color string. Okay. Using a backtick template string. Set the fill. Set the fill opacity. Ah, another property. Okay. So every time I run this program, yeah, I get a different set of random squares. Kind of fun. Okay. Not too hard once you see what's going on here. Okay. What about events? Oh, that's right. At the very top of that event hierarchy, we had like node. Well, beyond node, there's event target. So SVG element inherits from event target, and so supports every event that your browser can take. Okay. So let's try, okay, a mouse press detection example. Okay, I want to make my guitar chord SVG interactive. That's first step towards some kind of custom component. So I'm going to listen for mouse down events. Okay, so here we've got a bunch of guitar strings and such like that. I'm going to have a little bit of information about you clicked, blah, 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 blah. Let's open this up. Okay, not that one. Okay, so this is what this looks like. Okay, and so what I want to do is, we're going to watch here for the events, be able to click over here, okay, and be told what string and what fret they're pressing down on. Okay, over here should be 2nd fret, 4th string. Okay, weird guitar numbering system. 6th string, 5th string, 3rd, 4th string, 3rd, 2nd, 1st. Okay. Okay. So we can listen for those events. Okay. Where am I listening? Let's double check. Okay. Let's see some code. We saw that picture already. Okay. Main item is we're going to grab some items from the DOM for manipulation or event registration. We define an event handling function. Then there'll be some stuff with coordinate cleanup to try and figure out what's going on there. We're going to have a longer section on that for those that are interested in computer graphics. Okay. Register the event handlers. So what do we got here? So we get the guitar chord diagram thingy. Okay. We're going to get element by ID. Oh, these are where we're going to spit the outputs to. Okay. Go back. Go back. So in here, we got this little span that says X chord, Y chord. Okay, these have nothing to do with what's going on in the SVG. This is where we're going to output information about where things were clicked. Just like here, span ID string. This is just for output purposes, so we can see what's happening. Okay. Hit detection code. So those are just elements that exist. Okay. These all for spans. This is the SVG itself. Don't worry too much about this coordinate adjustment stuff. this is actually kind of it's a cheap and cheesy way to do it. But basically what I'm doing is getting the event, getting the client information, getting the event location of where the click occurred, doing some yicky math, and then spitting that back out, okay, setting the inner HTML of some of those elements. Inner HTML which elements? These guys up here, they're telling me where they clicked. So here, okay. Now, I rushed through that a bit because the transform method to understand the coordinates and whether I'm clicking string, one is particular to this guitar application. The other is it's not quite rigorous. Okay. So for those who have taken a computer graphics class or are interested in computer graphics, let's get a little bit more precise. Okay, if you're not interested in computer graphics, turn this video off. Okay, so basically, how does the SVG, the coordinates we do when we draw with SVG, and the coordinates that we get from the DOM, how do they compare? Okay, and how do we work with that? Okay, so there's a nice complete article about that, which is really pretty good. Okay, how to translate from DOM, meaning HTML DOM, to SVG DOM coordinates and back again. Okay, so HTML of the HTML page and SVG of your SVG diagram. Okay, how do we do that? Well, we're gonna learn about DOM point. Okay, or we're going to use DOM point. It contains an important matrix transformation method. Don't worry. Okay. SVG, graphics element, which is the base class for all the SVG shapes, contains an important function, getScreen CTM. What is that method? CTM, coordinate transformation method. Okay. So I want to go from coordinates in my local SVG shape and understand those coordinates with respect to the HTML page, not really the screen. Okay, the HTML page. Okay, these guys don't know about the screen, right? So, okay, that's how I go. But you're going, Professor, that's the wrong direction. That's going from SVG to HTML coordinates. Okay, well, that's okay. The DOM matrix and homogeneous coordinates in computer graphics. Those are the references. Okay, so let's walk through things. Okay, so I want to make a little doodle program. A what? You know, a program that I can do some drawing with. Okay. So right here. Okay. And so what I want to do is I want to be able to click on locations. Okay. And where I click, I precisely want to start a new rectangle, okay, whose top left corner is exactly where the cursor is. Not approximately, but exactly, okay? Because I'm making this doodle program. And if I click clear, it clears, okay? So I want to know exactly where to draw these things. I need those X and Y coordinates for the rectangle or square. Exactly. I'm doing the same random square generation as far as size, but not a position. Okay. So what did I do here? I set up this SVG. It's a trivial web page, as you can see. It's got one section in it. I'm not showing you the outer body and stuff. Okay. Doodle fun. Got a clear button. I give it an ID so I can grab it. I got the SVG. Okay, what else do I do? Let's see. Add a little CSS. Oh, no magic. Look here. Cursor, crosshair. When I'm over my drawing, ID, the SVG that has the ID, my drawing, the cursor turns into a crosshair. Okay, not that one. Okay. What do I mean by that? Notice my arrow when I go over the SVG, which I put a, here's the SVG, which I put a border around with CSS. Notice how it changes from a pointer to a crosshair. I did that on purpose to show a user that, hey, something wants to happen. Okay? There's a bunch of other cursors you can use, etc. Okay? Little bit of enhancement. These are the things that we have to control. Okay? Now, we want to see this all-important coordinate transformation. So what am I doing in this code? Getting the SVG, getting that drawing area, okay? Setting a max size variable of how big I let those things get, okay? Because I'm going to do random things, okay? Then I get the clear button. Okay, now let's see how this works. First step, okay. This is add the event listener for mouse down, mouse click. But it's really mouse down, okay? It doesn't include the mouse up. I could listen for mouse up separately. This is how people make drawing programs, on the in-browser drawing programs in particular. Okay, you differentiate between mouse down, mouse up, etc. Mouse over, mouse move, and things like that. Okay. So what am I doing here? First thing I'm doing is I'm using a method from the SVG to create what it calls an SVG point. It's a point, okay, but it's actually, very confusingly by the name here, it's something that's actually called a DOM point. Okay, this is more general than SVG. This is a DOM interface. Okay, this DOM interface knows how to transform itself. The next step, now this is an empty point, is I take that point and assign its X and Y values to the click location information I get from the event. Okay, so the event, right? So this happens on mouse click. Okay, now in a complicated step here, I say DOM point matrix transform. Okay, that means I'm going to apply a matrix transform to the DOM point. Okay, now working in computer graphics, we use a lot of matrix transforms, even for things that seem very, very simple, like just translating something over by a certain horizontal and vertical distance. Okay, these are general methods that have been used for quite some time now in computer graphics. They use them in 3D and in 2D computer graphics. Okay, so if you've taken a computer graphics course, you will understand that, oh, this is getting me the transform. Okay, this is getting me that transform matrix. This is also inverting that transform matrix. And here I'm applying it to the point. So this is going to take me this point we got from our event, from our click event coordinates, which are in the HTML DOM coordinates. Okay, this is going to transform those using this matrix we get from our SVG element, okay, over into the SVG coordinates. Why do we want the SVG coordinates? Because we want, when we create this square, we want to put it right where the cursor had been. We don't want any weird thing where they click here and the item shows up someplace else. That's very bad form. You will never sell a drawing program that does that. Okay, so let's take a look again at this. Okay, I got to clear things off, reload this. Let's look at the console. Oh, sorry, before we look at the console, one last thing to check. Notice the width here is 500, and the height here is 300. Okay, so let's come over here to the top left corner of the SVG and do a click. Okay, now it says the first point we get is 37 and 132. Which one is that? Oh. Where is it? Where is it? Where is it? Ah, that's actually the DOM point in HTML coordinates. Oh, so there's some kind of offset. Okay. It's about 37 or 132. If I look at the transform point, okay, the one in SVG, it looks very close to 0, 0. Okay. It also prints out, I had it print out that transform matrix. Professor, if we're in 2 dimensions, why do we have 6 entries in the transform matrix? This is a representation known as homogeneous coordinates that's used in computer graphics. In 2D computer graphics, it'll be a 2x3 matrix. Okay. By doing it in this format, it allows them to take into account translations as well as rotations and things like that. In fact, the last 2 elements you see in this matrix, E and F, are actually the translation. Look, they look very similar to the 37 and the 132 we got up here. Okay. Okay. So let's try clicking way down here. Oh, okay. Now we're seeing close to, that's the biggest X value. We said the width was 500. And we said the biggest Y value was 300. Okay. So that's what that matrix is doing. Okay. Those last elements are there to help with the translation. Not a very hard matrix to invert either. Okay, because first part's identity and the translation part just gets an opposite sign. Okay, so once again, this is the rigorous way to go about going from coordinates, and it's also very efficient because those matrix things, they're getting into the lowest levels of the graphics processing stuff. So they've been optimized to go quick because in SVGs, you actually nest transformations with transformations as you group things and rotate things and translate things and move things around. It gives you great pan and zoom and animation techniques and stuff like that. So working with these points and matrices is not slow. Okay. Okay. So that's the explanation. Okay, I know it seems a little painful, but it's only really create a point of the special type, set some code, set the coordinates of that point based on whatever you're trying to do, and then we run this transform. Okay, you go in the other direction. Say you wanted to put like an HTML element over on top of your SVG. Is a little simpler. Okay, so to recap, okay, we sometimes want to get very precise. Okay, and especially if we're trying to do a real guitar chord editor like this thing that I wrote here. Okay, so this is my guitar chord application. Okay, where it uses the good coordinate transformation stuff. So I can put in guitar chords and stuff like that and click on them and then drag and drop them. Yes, all made with technology taught in this course. Okay, well, plus some. Okay. Okay, so what did we do? We got that special point. Okay, it's a DOM point. We assign values to it. Okay. The reason we're using the DOM point is because it knows how to transform itself. Okay, it's got this matrix transform method. Okay. If you take computer graphics, you learn the theory, but now we have to understand how do we go from our theory to the practice. Okay, so here we use this point because it knows how to transform it. It's like I kept looking for How do I plug the point into the matrix? No. You give the point the matrix and it transforms itself. Sounds weird, okay, but the interface exists and I wanted to use it. Okay, so set the coordinates from the click location. Good, okay. Get the SVG to HTML DOM transformation matrix, okay. So this is the one that takes us from the SVG elements coordinates to the DOM coordinates, okay. Invert it to go backwards from HTML to SVG because we're going to add stuff to our SVG diagram. Okay, so that's inverse it. Then finally we transform the point. Okay, not too painful once you understand it. And if you've done some computer graphics, even better. You'll understand the theory, but it's still, even though you understand the theory, it can take a little bit to unwind and go through the interfaces, especially since these interfaces, some have more recently been standardized, so sometimes you won't find this stuff in books. Okay, so your knowledge of the DOM and creation and events can be applied to SVG. Okay, and so you can apply it to all sorts of nifty graphics. And there's a whole world of data visualization that uses SVG plus other things to make very stunning graphics.